Here's 2014 question 3. This is a graph analysis problem. And notice right away that the graph represents f. It won't always be the case, but that's the first thing that I go to, okay? Then I notice that they introduce another function, g of x, which is the integral of f, the graph. So just keep that in mind, okay? All right, here we go. So first part, they want us to find g of 3. Okay, so I have g of x here. So g of 3 is just the integral from negative 3 to 3 of f of t dt. What does that mean? When you integrate f, you're really finding the area under the curve, negative 3 to 3 in this case. So from negative 3 to 3, to 3. Okay, so at the very top, you could split it into two triangles or just see it as one big triangle there, just like that. So basically the area of that triangle is just a positive 1/2 times the base, which in this case is 5, and the height, which is 4. That should come out to positive 10. Now this triangle down here, since it's below the x-axis, we know it's going to be negative 1/2 times 1 times, that looks like 2. Okay, so that comes out to negative 1. So if you add these two together, you should get a result of positive 9, which is what we get right here, okay? They got 6, 4, and 1 because they split up this red triangle into two separate triangles, but it's really not necessary, okay? Here's part B. So on what open intervals from negative 5 to 4 is the graph both increasing and concave down? Okay, so these questions, there's a way to set it up so that there's no confusion here, okay? So what you first want to do, you want to write down the two statements. G is increasing and G is concave down. Okay, when G is increasing, G prime is positive. When G is concave down, G prime is decreasing. So a few things that you need to do. G of x is the integral of f. So the derivative of g is the derivative of that integral. And the derivative of that integral is really just going to be f of x. So take a look at the statement right here, okay? However g prime behaves, f will behave the same way. So for instance, if g prime is positive, f will also be positive, okay? If g prime is negative, f will also be negative. If g prime is increasing, f will also increase. Okay, and same thing, if g prime is decreasing, f will also decrease. So they're both equivalent. So this right here is basically the same thing as saying f and f. So where is f positive or greater than 0? Pretty much wherever f is above the x-axis. So pretty much wherever I'm highlighting in red here. Okay, now where is f decreasing? F is decreasing from here all the way down here. Now where do they both overlap? Right? It's looking like we're starting at negative 5 and we're going all the way to about negative 3. And then it starts back up again at 0 all the way to about 2. Since f is decreasing and f is greater than 0. Okay, that's one of the ways. Let's see what they said. They mentioned that there. Same thing. But there you go. Part C. The function h, they introduced a new function h here, which is g over 5x. Let me get rid of this for you guys so we have room. Okay, so C, we have this new function h of x, which is g over 5x. They want us to find the derivative at 3. So here, this is going to require the quotient rule, which is the bottom times derivative of the top minus the top times derivative of the bottom, which is just 5, all over bottom squared. So if you guys just plug in 3, that'll be 5 times 3, which is 15. Or you could just write it out. G prime of 3 minus G of 3 times 5 all over 5 times 3 quantity squared, or 15 squared there, okay? So the only thing left to do here is to figure out what G prime of 3 is and G of 3. G prime of 3, remember how we had G prime of x is equal to f of x. So G prime of 3 is really just f of 3. F of 3 is on the graph right here in blue. That's just negative 2. Okay? So I'll put in negative 2 there. Times G of 3 is what you found out in part A, which is just 9. That's enough for equal is equal. You could just leave it there. I wouldn't even simplify that part, okay? Here's the last one. Part D. Function P is going to be f of x squared minus 1. Find the slope of the tangent line to the graph of P at the point where x equals negative 1. So all in all, we need the slope of the tangent line. That's code for just derivative, okay? So how do I find the derivative of P of x here? So I know that P of x is f of x squared minus x. I notice that there's a function inside of another function. So this is going to require the chain rule. Okay? So P prime of x will equal the derivative of the outside of the same inside times derivative of the inside, which is 2x minus 1. Okay? So now we want to find the slope specifically at negative 1. So P of x here, P prime of x will now be replaced with P prime of negative 1. Okay, so here we go. So if I plug in negative 1 into the green quantity right here, I should get 1 minus negative 1, which is 2. If I plug in negative 1 over here in the blue, I should get negative 2 minus 1, which is negative 3. F prime of 2 is really just the slope at 2. So notice how at 2 you're on this purple line here. So however you want to do it, you could pick 2 points and then find the slope analytically, or I would probably just do rise and run. I noticed that it goes down 4 and over 2. So my slope is going to be down 4 over 2. Down 4 over 2 times negative 3 equals equal. I would just leave it there. That's it.